Comparing linear, polynomial, and exponential functions. We need to compare the functions f of x equals 50x squared and g of x equals to the x by completing each section here below. So I automatically know that with x squared, this is going to be a quadratic. And with x as an exponent, this is an exponential. So we want to fill in the table below. Note that we already filled in x equals 7. So we have the calculator to help us. Again, you could use this calculator or your own. So we want to evaluate the functions at each of these values for x. So I'm being asked to evaluate the function at 8. So we're going to do 50 times 8 squared. Then we want to evaluate the function at 13. So we'll be doing 50 times 13 squared. Then we'll be doing the function, first function at 50 times 14 squared. And then finally, the first function will be evaluated at 50 times 15 squared. So we'll go ahead and do that now. So 50 times 8 squared. This is 3,200. Then they want 50 at 13 squared. $8,450. And at 14 squared, $9,800. Then we want to do 15 squared. So 50 times 15 squared. 11,250. Then we want to do our second function, g of x. So we want to do what is g at 8. So we'll be doing 2 to the 8th power. Then we'll be doing g to the 13. So 2 to the 13th. G at 14. 2 to the 14th. And g at 15 will be 2 to the 15th. So again, we're just going to calculate those values. So to do that in the calculator, we'll want to take 2, and then we'll use this key right here where it says x to the y, and that will give us the exponent box. So 2 to the 8th, 256. Then we want to do 2 and the exponent key again to the 13th, 8,192. And then we'll be doing 2 to the 14th, 16,384. And then 2 to the 15th. $32,768. Now we're being asked to determine for x greater than 14. So we want to look at greater than 14. The table suggests that f of x will always, sometimes, or never be less than g of x. So g of x is going to get large very, very quickly because we are taking everything times 2. So f of x will always be less than g of x. So now we want to compare an exponential function, because x is in the exponent, with a cubic function, so to the 3rd power. Again, we're just plugging in these values, so I'm going to evaluate the function at 4. So I want to know what 3 to the 4th power is, and then we'll evaluate it at 6, 3 to the 4th power, evaluate it at 7, 3 to the 7th power, evaluated at 8, 3 to the 8th power. So I need to fix this. I actually need that to be the 6. So we want 3 to the 6th power. And then we'll evaluate the g function at each of those values. So I'll want to evaluate g at 4, which will be 4 times 4 to the 3rd power. G at 6 will be 4 times 6 to the 3rd power. G at 7 will be 4 times 7 to the 3rd power. And G at 8 will be 4 times 7, 8 to the 3rd power. So go ahead and do that for you here. So kind of had calculated those values for you and plugged it into our table. So now we're asked for when x is greater than 4. So we're looking right here. We want to compare the y values or the outputs. So the table suggests that f of x, and we want to compare it to being greater than g of x. So we look, f of x, 81, 729, 2187. So 81 is smaller than 256, smaller, but then it's larger. And then 6,561 is larger than 2,048. So we're going to choose sometimes is greater than g of x. So when you're comparing these functions, again, you're just going to be plugging in the x values from your table into your functions and then comparing f of x and g of x, and you're just going to read in part B where you are going to be comparing. Know that it can be always, sometimes, or never, greater or less than. So just have to compare the values to each other.